systems with attractors. Today we're going to be looking at how to actually create the particle system that we're going to be using to power the core of the effect. So I have a blank TouchDesigner open right now, and inside this TouchDesigner I'm going to drop the Particles GPU Watershed component that we created in the last project series, which was the terrain-based particle system. So if you guys haven't checked that out, I would recommend going back and doing that tutorial now. I believe that was part 2 of that series. I'll drop a link here, and I highly recommend that you go through this because, yeah, we're going to be using this component as kind of the starting place to do some work and get our particle system into a place we need to be. If you don't have time or you don't want to go through and watch the tutorial to complete this yourself, then you can just head over to Patreon, and all the project files and components are available there. Okay, so like I said, we dropped this down. A word about our project architecture. So I have my component here. I'm going to use this file that we have just started as the working file for the rest of this project, so everything will be added to here as we go. So I'm going to collapse. I'm going to call this maybe dynamic particles with attractors, and change this to a container so that we can give it a UI later on. Now this is going to be my main project component, so now we can start to build things out inside, and it'll give us a very easy way to keep track of all of our parameters, functionality, etc. So let's jump inside our Particles GPU Watershed and take a quick tour to reacquaint ourselves with kind of where we left off after our previous project tutorial. So here we're taking in a GLSL, which we're using to just create a simple UV map. We have a handling for vertical or horizontal aspect ratios. We're taking a color input, in this case just a simple noise, and then we're taking in some velocity input to actually use in our particles. As we can see, we also have some posts just set up already for us. And that's going to give us the ability to really start to fine-tune this effect without worrying too much about some of the low-level parameters, which are potentially going to be pretty helpful as we're working to get through this. So first things first, I want to add a little bit of complexity by using a fluid simulation as my velocity and replacing this procedural terrain height map with that fluid. Obviously this is just my preference. I like to have the fluid dynamics aspect in there. But yeah, you guys can either decide to or not to do that. This, again, is the fluid simulation that I have shared with Patreons in the past, so you can grab that on Patreon as well. Pretty simple. In this case, we're just going to grab our color. We're going to drag and drop that right into both the color map and density emit maps of our fluid sim. We're going to right click and add a null after the fluid sim and call this fluid out. And then we can grab the velocity output, and actually I will grab the velocity output with a GLSL, and then I will come in here, uncomment out the first line, remove the second line, then add a new second line and set color RG equal to normalize color dot RG to give us a normalized velocity map from our fluid. Then I'm going to wire that into the optical flow input of our particles, which you can see are now going pretty crazy. I believe that is because we should have wired it into... Yeah, we should have wired it into this weight GLSL from our existing network first, and then wire that into the optical flow, and that will allow us to use our gain parameter at the top level to control how fast we're moving. And that's definitely handy, so we want to keep that. So I'm going to just delete all of this because we don't actually need that procedural terrain height map at all. And then we'll wire the fluid color into our color as well. Finally, I will collapse selected here and just create this component for my UV creation, fix my parameters. I'll tell you what, at some point as I am working on more R&D tutorials, one thing I really want to figure out is how I can use some Python or clever programming to just auto-fix those parameter references when we collapse shit, because it's just so annoying. Anyway, alright, so now we have a fluid simulation. This fluid simulation is being piped in to our particles GPU. We're piping in both our color and our velocity, and we can see here that our color and our velocity are related, which is why I like to use this fluid simulation in this way, because I think it results in a very elegantly balanced visual aesthetic. With that said, we're really only using the fluid sim for our color and for our velocity, so we probably don't need this to be the full resolution that we have here. In fact, I think we can probably just limit our output resolution here to 512 by 512, and then our sim res we can also probably make 512. That will, excuse me, that will just have our computation in the fluid sim a little bit faster, reduce the weight on our GPU, because there's definitely going to be enough stress on the GPU from other stuff in the project. So potentially we can do an aspect corrected fluid sim, but this is probably the last adjustment we need to make on the velocity. So what I'll do here is actually start to customize my parent component, and as I'm dragging and dropping, creating different components and things, I'm just going to really start to alter this parent component as we go, just to keep things as clean as possible. So we already have a output resolution that's being passed to our particles GPU. I believe we do. So we can just open our parent parameters, and I'll drag and drop both of them, but then I'm actually going to just copy and paste this x, divide the y by it, then turn the x back to my 512, and then actually just come in here in the res y, and at the very beginning, type me.par.output res x .eval times, and then just simply multiply that x resolution by our aspect ratio from the parent component. And that way we'll have a nice, fully aspect correct fluid sim, but really not that high res because we don't need it to be very high res. We're just using it to add a little bit of visual complexity. Okay. So now we have this basis set up here. One thing that I'm going to want to do is actually jump into our particles GPU. And before I do that, I'm just going to look at the parameters that are already here. And what I'm looking for is our camera. I don't see a parameter for the camera. Let's check our parent parameters. Okay, so I want to take our particles and essentially just tilt them. And I want to tilt them so that we can do some cool perspective with our particle system a little bit later in the next tutorial. So an easy way to do this would just be to X-form our particles, not via translation, but just via rotation. And here we can see if we're rotating them to 90, that we're now looking at the profile of our particles. We can see some cool motion, and this is already somewhat interesting. So I'm going to customize this parent component. I'll go to the render page. I'm going to keep my translate to -80, I think, so that there's just a little bit of tilt. And I'll drag and drop this parameter to my parent. I go to my camera, and I think I can probably leave it for now. I'll just be happy playing with this rotation. We can see, especially if I get rid of some of this, that as we have our feedback, which is set to a pulse at the parent level, which means I simply need to connect my parent pulse to my local comp that has a pulse parameter that I will reference with op.local.par.pulse.eval, and that's because my local component has a global op shortcut called local. You can check out a tutorial I made on that topic that will show you guys how I do this, and should answer all questions there. So, before we do that, before we move on, rather, I'm just going to up our decay a little bit so that we get some cool trails appearing, but don't really have like the black, gray, faded out kind of watermarky effect. We're going to go and fix some of this and add some better posts later, but right now this just gives us a cool way to visualize what we're working on. And I really like the tilt perspective. So another thing that I want to do is add some color. To do that, I'm going to use this handy component called the Color Lover Palette Picker. It essentially just uses this website, which isn't loading at the moment. That's fine. I can link where to get this component, and we can just go through it. It looks just like this, and it essentially just lets you grab palettes using this API, the Color Lovers API, and then we'll just make little components out of them. So I'll share this link as well. But I have that component saved already, so I'm just going to grab it from here. If we right click and add a null to both of these outputs, we can see that one of the outputs is just a simple ramp, and the other is a DAT that contains some information, including the RGB values of our colors. We're not going to use the RGB color outputs from the DAT right now, but it is really handy to use sometimes, so good to know that that functionality exists. What else? You can turn the viewer on and just drag and drop selected. If you click on one, just drag and drop these palettes out so that you can use multiple. And then as you can see, when I do click on these palettes, our outputs all change, which makes it a very handy and interactive way to recolor some effects. It's also nice, it has new, which honestly I never really use because it's kind of random. As you can see, it looks like people use scripts to create some of these palettes a lot. Random is always good. Hue, you can select some hues and click Get Palettes, and then get palettes that contain the hues that you select, which is pretty handy sometimes. If we click on any of these, we can then of course just drag and drop them out like others. And then we can create favorites as well. So if there's one like this that we really like, we can just press this star, and then we will see it here. The one thing to note is that in a very, very annoying way, if you accidentally click on this delete, it's gone forever. So if you don't remember the name of your palette, you are somewhat out of luck. So be very careful if you are hanging out with the favorites view open and the viewer on. Be really careful that you don't accidentally delete things. For that reason, I try not to have it just set on favorites because I've lost some color palettes that I will probably never find again doing that. So we can grab this output, wire it into our color input of our particles GPU. Reset our network. This is not working quite right because it's all red. So we can go in and try and figure out what's going on. Well, we can see that the issue is definitely in our fluid simulation. And we can probably resolve this by, instead of just taking in the ramp directly, maybe we will take in the ramp and use a lookup a lookup to actually look up this ramp based on our noise. Whoops, these should be backwards. Based on our noise, and use that for our coloring instead. Some tweaks. First, we probably want to grab a palette and have in here as a default. So I'm going to wire this palette in and lock it just so it can be here as our default palette. And then we want to look up using just a monochrome, or turn it to not RGBA independent. You can do either of those things. But if it is set to RGBA independent, it means that it's going to be looking up different values for each RGB channel, which is going to result in a output map that is not limited to the colors of our input. Now this is kind of cool, and it can lead to some of the more high saturated candy looking type stuff, which may be desirable in some cases, but for right now I don't want it. So for right now, I'm going to change this to luminance. As you can see, we're now already getting a pretty cool palette that is shaped like our noise, but is colored like our lookup. We can give one of these noises, maybe this one, the second one, a bit of translation. So I will customize my parent component. I will add a parameter called time. I will make it a float. I will add it. I will reference it here with parent.par.time.eval times 0.2. And then I'll go to my parent component parameters. And I will set this to abs time.seconds times 0.5. Now we have our color translating a little bit. We have it fully looked up in a very nice, smooth manner. One thing I guess I will note since we're here is that let's say we wanted to keep it RGBA and decided instead to make this noise monochrome. So as you can see, that's a somewhat similar effect. If we look at the range of values here, we can see that our range of values in this noise is going from -1 to something over 1. This lookup range takes a lookup in the range 0 to 1. So if you have values that go outside of that range, you're losing lookup information. So you can either have our input pixels, something that is ranged to 8-bit, which is suboptimal in many cases. Or you could use the lookup range to look up from a range that is wider, like a -1 to 1. Now this is very wide because it's all the possible values that our two noises could create. But it's good to know that, for example, by turning the offset down and amplitude up, although it actually only needs to be up to 1, that we can use our lookup top and lookup map in a variety of different ways to get some much more complex results. So I'll just put all of this back to normal, and I will look up based on luminance. Alright, and so with that, I'll turn off our lookup viewer. So now we can see that our coloring is working a lot better. I'm going to change some parameters on my fluid. I'm going to drop the flow way down to something more like this. And I want that so that we can retain some more depth in our color and it's not just all super bright. We can change the coloration parameters. I actually kind of like the Reinhardt extended with a value that's a little bit lower, like maybe 0.13. This will also need to change as you change your inputs, so I wouldn't stress out too much about it. I'm going to turn velocity fusion up to like 0.3. My decay I'm going to turn down to like 0.1. Color diffusion to 0. Pressure passes I will put at probably not 50. I'm going to put pressure passes at 20. We want those to be higher than 1, so like if I go down to 1, you can see we're losing a lot of detail in our fluid sim, but we don't want it to be like crazy high just for performance. So you can see right now our whole fluid sim is running with like a millisecond or less of GPU time, which is pretty good. We definitely don't want it getting higher than that. Color diffusion set to 0, velocity diffusion set to 0.3. My velocity scale I'm going to turn down the whole way to 1, actually. That's just because we don't need this moving crazy fast. And then pressure we'll leave somewhere around 0.8 and vorticity somewhere around 8. And now we can start to see some of this cool tilt-shifted particles that are driven by our fluid and are being colorized by this lookup noise that is then being passed into our fluid. Something that you may want to consider is just using this color top directly as the color input. That will lead to a little bit more defined boundaries between areas of color and may or may not be desirable in some cases depending on what you're going for. I'm going to leave it as the fluid for now though because I like that. Okay, so now that we've got the color all set up, what we're going to do is figure out how we can get some controlled vertical motion. So we have our turb magnitude parameter. This was from the original creation of our component from the last project. We can see when we reset that this does introduce some cool vertical motion, and if I rotate this to be a flat line, already looking kind of cool, and we can see the vertical motion here. Real quick, I'm going to set my life to something like, say, 16, and then my variance, I'm just going to set to half of that to give us as even as possible birthing of our particles. I'm going to turn my turb magnitude down to 0 again, and so now we can see we just have this flat line here. What I want to do is be able to use a passable map or parameter to be able to add some vertical velocity to our particles, and I want to do that using the same map that we're passing in here, which is our optical flow input to the particle's GPU. So we are just using that input. If you remember from last time, we're repurposing it. This is still calling it optical flow, but it really is just a velocity map input. So what we want to do is be able to take that, add some vertical velocity, and to do that, all we need to do is jump inside, click on our multi-compute particle shader, edit that, and if we just Control F for optical flow, we can see there's this external input function, which is where our optical flow force is being applied in our shader. Now, we can see here that we're only reading in the X and Y components of our optical flow texture, and to read in a Z component also, it is pretty easy. We can just add our Z vector components there, so now we are applying to all three components of force the looked up value from this optical flow texture. That is actually all that we need to do on the GLSL side of things. Now, we don't see any action here, and the reason that we don't see any action is because we are still passing in RG format textures, and we need to be passing in a B value if we want a vertical. So I'm going to change this to 32-bit float, RG. And then we just need a vertical measure to pass in. So I'm going to middle mouse on our fluid. I'm going to pick a slope. I'm going to set the red equal to vertical luminance. I'm going to set the 0 point to 0. Then I'm going to right click, add a reorder top, and wire the velocity normalized, which I'll rename now for good measure, normalize the velocity. So I want my red to be input 2 red, green to be input 2 green, blue to be input 1 blue. And if we change our slope intensity here, we can see that coming in. Move this back down to 1. And we can just wire this right into our GLSL. And now we can see some vertical motion happening. We can then change and control the vertical motion using this slope strength parameter. So if we have it set to 0, that obviously means that we have no measure in that direction. Kicking it up to 1. So we can already kind of see some pretty cool effects happening as we add our vertical velocity like this. I'm going to do a couple things to clean it up. I'm going to drop a select. I'm going to select this fluid out, wire the select into my slope. And we have our gain here on our GLSL, so I'm going to leave that outside, but I'm going to collapse these guys and say calc vel map, name that component. I'll name this top apply gain. And then I'm going to customize this vel map component and give it a parameter called vertical strength. Then we can open the parameters. We can jump inside this component and we can set our slope strength. We can set our slope strength equal to this vertical strength component here. Now we can see we're reading in RGBA, which is great, but we only need RGB, so I can set these to 32-bit float RGB pixel formats and save us a little bit of computation. So now we have our parameterized Velocity, in the vertical direction, we can see now this is at 0, and as I kick it up, we do indeed start to see our vertical velocity appear, which is awesome. So I will now turn my view back to -80 to get some of this cool perspective, and we can see that vertical velocity and differentiation happening across the board here. And then, just as a reminder, we can super easily change our color just by clicking on a new color palette. And we will see that our colors will slowly change, which is super nice. Alright, we are getting pretty close to wrapping up this section of the project. The last thing that I'm going to do before we kind of move on is jump back into my particles GPU and set up a quick depth blur. The depth blur we can set up using a technique which I will be talking about in a soon to be released quick tips tutorial. That is using a object chop to calculate a dynamic depth measure. So we can drop our camera into the reference, we can drop our geo into the target. On our object, we go to the output tab, we change our compute to measurements, we turn off position, we turn on distance. That gives us a measure, which is going to be the distance from our camera to our geo. So if I view this and then in our geo, I translate in the z direction, we can see that the distance measure is actually changing there. And that is super helpful because it means that we can use something that needs a range, like a depth top, and we can actually change our depth texture to a 8-bit fix, change the input space to rearranged from camera space, and here we can simply just take this, drag and drop it onto our to and our from. Something handy that I then will do is simply multiply the near by 0.5 and the far by 1.5, and that gives us this nice gradient that has our near values very dark with no white, and our far values white with the gradient in between. You can then use the gamma to kind of control the fall off. So I'm going to put the gamma to something like 1.5, maybe 1.6, 1.6, and that gives us a fall off curve that I like. Oops, and then I'm going to go after my anti-alias, right click, insert a Luma blur, drag that depth top in there, and just like that, we have a nice depth blur effect. I don't want to turn the filter width up too high. I'm actually going to keep it just right at 7, the default settings. And the reason for that is if I do Alt-4 to open up my top viewer and then middle mouse and zoom, we can see that we're already getting some of these kind of halo-y effects at the lower white filter sizes. That's not going to be super noticeable, but I don't want it to get any worse. So now we have a little bit of perspective that we will use to make a little bit more sharp in the next tutorial. And then the very last thing that I'm going to do here, now that we have our object chop working to get some dynamic depth ranges, what I'm going to do is turn off all of those viewers. I'm going to customize my parent component. I'm going to go back to the render. I'm going to grab the translate for this geoparticles. I'm going to put that translate right by my rotate parameter. I'm going to then customize my particles GPU watershed component and make sure that I take that translate, drop it on there. And now, if I go up to my super top level, what we can see, especially if I turn our feedback decay way up so it's not really doing much feedback, is that as we translate the Z component, our particles will get closer, our particles will get further, but we still maintain this kind of depth effect where the particles closest to us are the sharpest and the ones furthest away from us are less sharp, which is also very handy as we do things like animate the camera and just kind of continue to play around and iterate as we are developing this. Okay, final thing for this part of the tutorial, and that is I'm going to add a null. I'm going to have the camera look at this null, and the null is just going to be placed at 0, 0. Actually, I can probably just have it look at this geo and not even need the null. There's a cook loop. That is because of the object chop, so actually I'll use the null. The loop is because we're using the object chop to pull in the camera and the geo, which we can see if we do this, but it's fine, it doesn't really matter. I'm just going to drag my null onto my cam look at parameter. And now, if I customize my parent component again, go to render, take my camera position and drop it on here. Call this cam translate. I'll call my particle translate particle geo translate, and then I'll call my rotate particle geo rotate. And finally, the same on my component one level up for my cam translate. I will call this my particles geo translate, and then my particles geo rotate. Very good. And now again at the top level, we'll change color one more time. And now, because of that look at, as my camera moves up or down or around, we maintain a view direction that's pointed at our particles, which lead to this kind of perspective panning, which is pretty cool. So one thing that we'll be looking at later on is as we look at camera transitions and kind of building an effect into a project, we'll use camera transitions a lot for just introducing some dynamics and interest. And as you can see, like, I haven't changed anything but our camera and the color, and already it's a very different appearance that looks pretty cool. So that is using something very simple, just that look at, and I actually kind of like this like below looking up view, kind of cool. I'm going to go back to 0, 0 for now. And I'm going to then turn, before I finish, I forgot to, on my particles page, drop this vertical strength. And because it's at 0.8 and already we can see quite strong, vertical motion. I'll make a change. I'll come in here and I will just divide this by 10, which will give us a lot more fine-tuning ability. We can come in here in particles, and we can turn up our vertical range, or turn it down, turn it up just a little bit. And we can kind of start to see this like particles splashing from the fluid effect which is appearing here. Okay, so now we're actually done for today. In our next session, we're going to be looking at ways that we can continue to deepen and refine the post process here to really make some of this stuff pop. And I look forward to that very much. So for now, I will leave you guys. I will say thank you to my Patreon supporters. As always, I really appreciate all of the help and support. These project tutorials are a lot of fun, and hopefully that they are helpful for people who are trying to figure out how to kind of string together techniques to build more complex works. And I will look forward to talking to everyone next time.